Alright, our last proof is a little bit more involved. It's not any different as far as the process, but the fraction work just makes it a little bit more complicated. So I'm going to show you two different approaches to this problem. We'll go through it. If one stands out to you, go with it. Somebody else might think another one stands out to them. So cosine times, we've got tangent plus cotangent in my parentheses equal to cosecant. So left side, more complicated, we're going to change that. Can't do anything to the right side. So now what we have to do, I'm going to change everything into sines and cosines. I don't see anything squared, so the Pythagorean identities are probably not going to happen right now as far as how it's written. Cosine is cosine of theta over 1. Then we've got tangent, which is sine of theta over cosine of theta, plus cotangent, which is cosine over sine. So I've just changed everything into sines and cosines. From here is where there's two different approaches. I personally like to distribute this cosine through, so we'll go with that first. Other people like to get a common denominator and push these together, then multiply. So I'll go through both approaches. So the first one, we'll distribute. We have cosine of theta, sine of theta over cosine of theta. That's what happens when you multiply it through to the first fraction. Second fraction, we get cosine squared of theta over sine of theta. Alright, so now if we're looking at these, well, let's see what we can do. We can cancel out the cosines in my first fraction. There's one in the top and bottom. Nothing cancels in the second. So we've got sine of theta plus cosine squared over sine. Now I see that I have the addition of two fractions, so I'm going to have to get a common denominator. Well, between my two denominators, sine would be that common denominator. So I'm going to multiply this one by sine over sine, which makes it sine squared over sine. So all we did was we got a common denominator. If we push these together, we get sine squared of theta plus cosine squared of theta all over sine of theta. Now as soon as I see something being squared, in my head the Pythagorean identities kind of pop out, because I know those are the squared identities that we need to be dealing with. Sine squared plus cosine squared, that equals 1 from my Pythagorean. So I'm going to replace that numerator with 1. So we're left with 1 over sine of theta. Reciprocal identity, 1 over sine of theta is cosecant. Well, that's what we were trying to prove in the beginning, so we have just proved it. So now I'll go back here. This was one method. Off to the right, I'll go through and I'll simplify it if you want to get a common denominator from the very beginning. So we've got cosine of theta over 1. Here we've got cosine and sine, so my common denominator is going to be cosine sine, cosine sine. This is going to fall off the board. So here I had to multiply by sine, so we get sine squared of theta. This guy I had to multiply by cosine, cosine squared of theta. So we can go through and simplify. Cosine of theta over 1 times sine squared plus cosine squared all over, I just changed it around, that's okay, same thing, sine cosine. Then I could go through and distribute if we wanted to, or we could change out to the Pythagorean. So once again I've got something squared, so I know sine squared plus cosine squared is 1. So we'll do cosine of theta over 1 times 1 over sine of theta, cosine of theta. Now I can push this into my equation, so that gives me cosine over sine cosine. Cosines cancel. We're left with 1 over sine of theta, which, due to the reciprocal, is equal to cosecant of theta, what we were trying to prove in the beginning. So this is two separate methods. You do not have to do both. You pick whichever one stands out, and you might do one for one problem and then switch to another for another problem. It just depends on what pops out.